Hi, grade 12. Uh, Welcome to this session. Thank you for joining me today. And today I just want to introduce to you what you see down here, trigonometric deep learning. This is deep learning 2. Our deep learning 1 was on nature of the roots, and today we're gonna be strictly focusing on trigonometry, and we'll be actually dealing with question 5, giving you the strategies and tricks on how you can solve question 5 of trigonometry grade 12. Okay, enjoy this lesson. Thank you. Okay, grade 12. We're just gonna start with this one. It's a trigonometric expression. We are actually gonna be focusing on question 5, like I said, and today we're gonna be focusing on expressing trigonometric ratios in terms of something. Then let's first look at this example. They said if cos 73 degrees cos 31 degrees plus sine 73 degrees multiplied by sine 31 degrees is equal to k. Then let us determine the value of k let us determine the value of the following in terms of k. Very important statement. So we are just basically gonna determine these two expressions in terms of k, right? Given that k is equal to this big equation here. Okay, so how do we do this? Like I said, this is a trigonometric expression, and trying to express trigonometric ratios in terms of certain unknowns. So now what you do on this question, you use your given information in order to answer these questions below, right? So you use your given information. So let us see. We have cos 73 cos 31 plus sine 73 sine 31 is equal to k. But also we know that we can simplify that expression, that equation to be, we know it's cos cos sine sine, therefore it's compound angle of cos, then it will be the same as cos a minus b, right? So it's the same as cos a minus b. Because it's compound angle of cos. If the sign is positive, you just change it in middle to be negative. So where our a is 73, our b is 31, right? So we're just gonna say cos 73 degrees minus 31 degrees is equal to k. So we just use the rule there. Remember, we're still working with our given information. We haven't started answering the question. We're just trying to simplify our given information. 73 minus 31, it will give me 42 degrees. So this is the same as cos 42 degrees is equal to, it is equal to k. So now let us, I think there's nothing much that we can do, or someone can say, okay, there's still something you can do from your given information. We can do that. 42, we can multiply a certain number by 2, then it will give us 42, then that number is 21, right? So it's 2 times 21 degrees, it will still give us 42. 2 times 21 is 42. Then we can simply say, okay, then this can be changed into 3 things. Remember, now is double angle of cos, right? It's like cos 2 into 21 degrees is equal to k. Someone can change this to say this is gonna be 2 cos squared 21 degrees minus 1 will be equals to k. Or someone can say it's gonna be 1 minus sorry about this, 1 minus 2 sine squared 21 degrees is equal to k. Or someone can say, I can change it to be like cos squared 21 degrees minus sine. Okay, let me just change the color there so that you can be able to see it. I don't know if I can use black. Then it will be cos squared 21 degrees minus sine squared 21 degrees is equal to k. Then that's it, right? So we haven't started solving the question, right? So what's very important when you're given an expression on an equation, try to first simplify it and apply all the rules that you know as far as possible as you can, right? So then after that, it will be simple for you to just go to the question, just simply solve it straightforward. You just get the answer, simple like that. So that's what you do when you want to express trigonometric ratios in terms of certain unknowns, such as express this in terms of this, in terms of k in this case. So now what we did, we used our given information and we just applied the rules that we know, and then we just simplify it like that. Then now we can go to the questions and solve them, right? Okay, let us look at A. Let us look at A. I'm just gonna put it here. So it says express the following in terms of k. You are given cos squared 21 degrees minus sine squared 21 plus 7, right? Express it in terms of k. So we already know what cos squared 21 minus sine squared 21 is. Here's it, right? We just simplify our given information. That's all you do. So then after simplifying it, we get that cos squared 21 minus sine squared 21 is k. Then we can replace that with k. Then it just be k plus 7. Very simple to express it, you see. So other than stressing out yourself and all that. So we know that cos squared 21 minus sine squared 21 plus 7 will be equals to k plus 7. So we have expressed it in terms of k. Okay, let us now move to B. B. They said express sine 42 in terms of k, right? Sine 42 in terms of what? In terms of k. Okay, we know that sine 42 can also be written as what? It can also be written as, someone can say, we can write it as a double angle of sine to say sine 2 into 21 degrees. Why are we doing this? Because we know that our given information, we have 21, you see, we have 21, so we can just simply use it like that to express it in terms of k. So now this is gonna be, we can use the double angle of sine. It's got 2 sine 21 degrees multiplied by cos 21 degrees according to the rule, right? According to the rule, right? So it's like that, 2 sine 21 degrees times cos 21 degrees. Okay, then now let's look. We can actually solve for cos 21 degrees using this equation in terms of k, right? Look at this equation here. We can actually solve for cos 21 in terms of k, and then from this other equation we can now solve for what? For sine 21 in terms of what? In terms of k. Then we can just simply express it in terms of k, right? So that's another method you can do, but although it's going to be a long method, right? So let us try a simpler method. Okay, so from this equation, equation, it says cos 42 is equal to k. We can actually use it to get the answer for sine 42. How? That's the question, right? Remember, I said with this one, it's going to be a long procedure where we're just going to first solve for sine 21 this side, then we replace it. We solve for cos 21 that side, we go and replace it, then we have expressed it in terms of k. But simply, someone can just say, no, that's a long method. How about we use this one, cos 42 degrees, which is equal to k. But how are we going to use it? That's the biggest question. So we know that what we can do, sine 42 is the same as root of 1 minus cos squared 42 degrees. Don't forget, this is from what? If we say 1 minus cos squared 42 degrees is the same as what? It's the same as sine squared 42 degrees, right? 1 minus cos squared 42 is the same as sin squared 42 degrees. If you apply the root to the squared cancel, then you still have your what? Your sine 42 degrees. So that's another strategy that you can use, right? So yeah, we just gonna simply use this one because it's very short and simple. So what is cos 42 is k, then it will be k squared, right? So this is the same as root of 1 minus k squared. So that's the final answer for sine 42 degrees. So it's actually a bit tricky, but you just play around your given information and try to solve for the unknowns, simplify as much as you can, then you're just gonna be able to express it in that other way. Okay, grade 12. Let us look at this second example, and we're still on expressing trigonometric ratios in terms of something. And here's our given information. They say if cos A plus sine A is equal to k, so that's the equation. Express the following in terms of k. We are given number A is cos A minus 45 degrees, right? So in the previous example, how did you do it? We use our given information in order to express the questions that we were given in terms of k. But now this is quite different because our given information does not remind us of any rule, right? So there's no rule that you can say I can apply a certain rule here in order to maybe simplify it. It's already standard. It's already seated in its simple form, right? So in this case, where you find that your given information is already seated in its simple form, you use the questions now in order to express them in terms of those things of k. So now we just gonna go straight to the question. We are given cos A minus 45. We know that this is a rule, right? Compound angle of cos. So we know it's cos cos and sine sine, right? So it's just going to be cos A multiplied by cos 45. If the sign in the middle is negative, this one will change to be positive, right? With sine, we keep the sign, but with cos, we change the sign. That's it. So then it's going to be sine A multiplied by sine 45 degrees, right? Very interesting question. So look, cos 45 and sine 45, 45 degree is a special angle. Therefore, we can change cos 45. Then it's just going to be 1 over root 2. Or sometimes you might know it as root 2 over 2. It's not a problem. Then sine A, sine 45 also is 1 over root 2 or sometimes root over 2. Then yes, then look at this now. We have a common factor of 1 over root 2. We're just going to take it out. 1 over root 2 is our common factor. We are left with cos A plus what? Plus sine A, right? Very interesting question. Look at this now. We are done. Cos A plus sine A, it's what? Given information. Cos A plus sine A is k. Then we can simplify. It's going to be k over root 2. So we have expressed our first expression, cos A minus 45, in terms of k. It is k over root 2. Okay. Okay, let's now look at our expression number B, and it says we are expressing this in terms of k. We have to express it in terms of k. So we have 1 plus sine 2a. Wow, 1 plus sine 2a. So this is a little bit tricky question that most students will struggle to get, but let's see how it goes. So 1 plus sine 2a, obviously we can see the rule there. It's going to be 1 plus. We can change sine 2a because it's double angle of sine. It can be changed into 2 sine a cos a. That's the rule. 2 sine a cos a. Now, what do we do? Do we have 2 sine a cos a on our expression? No, we don't have it, right? We don't have it. What else can we change from this expression? 1, right? Look at 1. We can change 1, right? 1 can be changed into, there's a rule that says sine squared, because they are using a's also, as we're going to use a plus cos squared a. Sine squared a plus cos squared a, it will give us 1. It will give us 1. Then plus we have 2 sine a cos a. 2 sine a cos a, right? Okay, let's now look. We can just actually arrange it in a way that we can be able to factorize. Then I'll just write it as sine squared a plus 2 sine a cos a plus what? Plus cos squared a. I'm just writing it in a way that I'll be able to factorize, right? So from here we can factorize. It's now factorizable. Then we can put sine a there, sine a there, so that sine a times sine a to still give us sine squared a. Then I can put cos a here and cos a here, so that cos a times cos a to give me cos squared a. To get 2 sine a, then it must be plus and plus, right? So now look, we actually have simplified, we have expanded it and factorize it in a way that it gives us something related to the given information. That's basically what you do. You have to fight to express it in that way, right? Then after this, what can we do? We can just go and replace. Sine a plus cos a, it was k. Sine a plus cos a, it was k. Then that equation, that expression will just be k times k, which is k squared. K squared. So this was not an easy question, but you can see that we just applied the rules and factorized and just simply express it in terms of k as they needed it like that. Okay. Okay, grade 12. Let's continue. And now we just have a different problem. We're still on question 5, as you can see. And this is trigonometry expressing trigonometric ratios in terms of something. So now you are given cos 2 theta is equal to minus 5 over 6. This is a very, very likely question that you can get in your examination question paper. So they said if cos 2a is equal to minus 5 over 6, where 2 theta is the element of 180 degrees and 270, 2 theta is between 180 degrees and 270, then they are saying calculate without using a calculator the values in simplest form of 5.1.1 sine 2a. So if you are given this question, this is the question that you likely find in when you are starting your question 5 in your paper 2, right? You'll likely find this question. Very, very rare that you get a question paper without this kind of questions, right? So they gave you cos 2 theta is equals to minus 5 over 6. This is very different from the previous question we've been solving. In the previous question, we're just given trigonometric expression expressed in terms of letters. But now you are given trigonometric ratios expressed in terms of numbers, and then you are given that that angle is between certain intervals. So before answering this question, what you do, you go and draw your triangle, and you must know where your triangle sit, right? So I'm just gonna use black pen here. This is my Cartesian plane. First quadrant, second quadrant, third quadrant, fourth quadrant. Here I get all, right? The soccer tower thing. The soccer tower. No, let me not use the soccer tower thing. Here I have all sine. Here I have cos. I have tan. Here I have what? I have cos. Yeah, it's like this. So that's your Cartesian plane. Here we have sine. It's the quadrant for sine. This is the quadrant for tan. This is the quadrant for cos, right? So cos lies in the fourth quadrant and in the first quadrant because all of them lies there. So they are saying cos 2 theta is equals to minus 5 of 6. It means that your cos is negative. But look, your 2 theta lies between what? Your angle lies between 180 and 270. So this is 0, this is 90, this is 180, this is 270, and this is 360. So your angle is between 180 and 270. It's between here. So this one is simple because you already know where your triangle is going to lie because the angle is between 180 and 270. 180 and 270 is this quadrant. And you can see in this quadrant we get tan. Hence, your cos will be negative. So very important to be able to interpret it. So we're just going to draw a triangle. Then we have our 2 theta there. Then after that, we know that cos, it says what? Adjacent over hypotenuse. So the negative will go to the adjacent. As we know, this side is negative. We get the negative x value. So negative 5 will be on our adjacent. Then our hypotenuse is never negative. It just be 6. Then we have to solve for y, right? How can we solve for y? That is a right angle triangle. We're gonna use theorem of Pythagoras. Theorem of Pythagoras. So theorem of Pythagoras, hypotenuse squared is equal to the sum of the other two sides squared, right? So that's it. Then I'm just gonna solve for my y here by taking that 5 to the other side. Then equals to y squared, 6 squared, 36, 5 squared, 25, 36 minus 25, 11, right? It's 11. Then it's just gonna be 11 equals to y squared. Then my y will be, I'll apply square root, but when I apply square root, it's plus or minus 11, right? So y is plus or minus 11. Many mistakes that students make, you find applying square root and just say y is equals to root of 7 or root of 11. See, it's incorrect. When you apply square root, you say plus or minus. Then you can now check your y. Let's check our y now. Our y is on the quadrant where we have the negative y's, right? We have the negative y. So your y will be equals to negative root of 11, not positive. So you have to be very careful while drawing that triangle and trying to actually fill it up. So it's our y is negative root 11. So that's it. Okay, so let me just erase this and just go straight to the question. So I have my triangle. There's no need to put in a Cartesian plane anymore. I have it like that. But you just keep it on your Cartesian plane. Me, I'm just doing this for space. So let's see. They are saying express the following without using a calculator. Calculate the value, the answer of this thing. Sine 2 theta. Sine 2 theta. We have our triangle. It's going to be very simple. Sine 2 theta. Sine is opposite over hypotenuse. What is your opposite? Your opposite is negative root 11. What is your hypotenuse? 6. You are done. You get your answer. Minus root 11 over 6. As simple as that. Okay, let's look at this one. Sine squared theta. Look at our triangle. We don't have theta in our triangle. We have 2 theta. We have 2 theta. How do we solve this one? Now, how do we solve it? That's the question. We have 2 theta in the triangle. We don't have theta, right? So with this kind of question, you go and use your given information, simplify it in a way that you will write it in terms of sine theta, then come and replace, you get your answer. That's it. What is our given information? Let's look at our given information. Our given information, we are given that cos 2 theta is equals to minus 5 over 6. I'm going to simplify my given information in such a way that I will simplify that angle to be theta. Then I can express sine squared theta in terms of those values. Right. So that's what you do. We know that there's a rule here. We can simply change this rule to sine because here we want to solve sine, right? When you change it to sine, to be 1 minus 2 sine squared theta is equals to minus 5 over 6. You can see now we can be able to solve for our sine squared theta, right? So it's called the indirect approach. You actually gonna solve for this question indirectly or silently. How? By using the given information. Simplify it in such a way as that it will be expressed in that way, then solve for it. So we're just going to take 1 to the other side. We'll be left with minus 2 sine squared theta is equals to minus 5 over 6 minus 1. 1 is positive. When it goes that side is minus 1. So minus 5 over 6 minus 1 is going to give me minus 11 over 6. Then if I divide minus 11 over 6 by 2, then by minus 2, I'm just going to get positive 11 over 12. So my sine squared theta will be equals to 11 over 12. Then I've solved for my sine squared theta. So this is an indirect approach that many students are not actually aware of, but I hope after this lesson you are just going to be aware and practice a lot of questions related to this, and you're just going to be fine with your examination. So let me repeat it. How do we do it? We saw that in our triangle we had we have no theta. How did we solve it? We used the given information and actually simplify the given information in such a way that it can give us that theta, that sine theta, so that we can actually determine the answer. So it's the indirect approach, as I said, and it's very interesting like that. Okay. Oh, great top. This marks the end of our session today. I just wanted us to focus mainly on trigonometric question 5, expressing trigonometric ratios in terms of something. Thank you very much for joining me. Thank you very much for watching. Don't forget to subscribe if you're new to this channel, and just check up on our other videos. We have counting principle, trigonometry, number pattern, and all that. Thank you very much and enjoy the rest of your day. Goodbye.